Testing, 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 testing. Microphone. Microphone's thinking about it. There it goes. All right, I got closed captioner now. All right, cool. That works. All right, I got that going. Minimize that. That could be heard, which is kind of the idea. All right, cool. All right, that's better. Hello, everybody. Yes. Tonight we're going to pick up with day 14 of 30 Days Lost in Space. This particular day, I was reviewing it, is going to continue with the security panel. We're reusing some of what we previously had wired, and adding a little bit more to it. So let us get started. I don't know how long this one's going to run, since we already have the existing wiring from last time, and we're just going to kind of tinker with the code here. So we're just going to run through it, not really rushing, but don't be surprised if this doesn't go longer than an hour, as I kind of don't think it's going to be honest. Let's see here. I want that one. Haha! Alright, excellent. Alrighty, I'm going to suspend the background music, and we are going to hop into it. Also, remember to hydrate. I love that.
Good morning, intrepid explorer. It's time for our final day of our third week together, and I do hope you're as excited as I am. Today we have a delightful rendezvous with our former crew member, the RGB LED. We'll be integrating it into our setup and taking our control panel from functional to fabulous. Today we'll be transforming our buzzer's simple beep into an expressive and nuanced system of auditory feedback. Not only that, but we're going to coordinate it with our RGB LED to provide clear visual cues depending on your pin input. Think of it as a form of immediate feedback. When you successfully input your pin, we will immerse our spaceship in a comforting green light. On the contrary, if your input fails, we will be met with a piercing red light as a sign of incorrect input. Green for go, red for no. It's so universal that even a celestial body could understand. Since there are no new
celestial, you
components
say?
today, we will be diving headfirst into the coding and wiring. Ready to create a sophisticated and intelligent spaceship? Let's get started. All right, time for some wiring. If you remember how we set up our RGB LED last week, you're already one step ahead. Today, all we need to do is to merge that RGB setup with our current control panel configuration. Think of it as a bit of a celestial, or I guess aquatic, engineering. We're taking two previously independent systems and merging them into one harmonious unit. It's quite beautiful, isn't it? We're building a network of devices that can interact and coordinate with each other in a most splendidly efficient manner. Just remember to ensure your wires don't look like a tangled seaweed cluster. We need our circuits clear and our paths unobstructed. Once you've achieved this glorious fusion of wires and components, we can shift gears and explore the vast depths of coding. Buckle up. It's about to get exciting. All right, my fearless bottom-dwelling mechanic, it's time to lay out today's game plan. Here's what we're aiming to do. Step 1. We want to bathe the RGB in an emerald green glow when our system is either unlocked or a correct password has been punched in. Contrarily,
All right.
let it flare up with fiery red rage when an erroneous input infiltrates the system.
Be gone, heathen!
Step 2. Let's turn that buzzer into our personal symphony, composing melodies of success and failure as needed. Step 3. Moreover, we'll make that buzzer emit a brisk beep every time a button is pressed during the pin input sequence. While we're at it, why not manipulate the RGB's hue to shades of yellow or blue? This way, we can visually signal that we're in the midst of pin input. It's clever, no? I've been tinkering with a plan, and I've decided that the most efficient and organized way to handle all this is by developing 3 new functions. 1 to express success, 1 to denote error, and 1 to indicate ongoing pin input. Plus, we'll breathe life into the RGB LED color function from last week. By now, creating new functions should be as easy as breathing for you, my dear spacefarer. As for our friendly buzzer, let's make it sing by using the tone function. A high-pitched note will be our anthem of victory, while a low, solemn tone will signify defeat. The bones of our code will remain as sturdy as they were yesterday. Don't forget to add a tiny update at the top to define our LED pins. As usual, I've crafted a line-by-line explanation of today's code and added it to your mission resources. While it builds on what we did yesterday, I highly recommend giving it a look over. Your survival does hinge on understanding this, after all. Whew! The days sure are flying by, Explorer. Now seems like a great time to grant me a well-deserved break as you review some instruction material that I have gathered, cached on your computer. As you know, I've also added this to your mission resources in case future you needs a bit more assistance.
Current me, thank you.
Hello, everybody.
Current me is thanking you. Very much so. Alright. So we are going to be messing around with the colors, which is fun. So yeah, from the previous day, we had integrated the keypad and the buzzer. And what we're doing is we're bringing back the RGB LED. Now, this, we played around fairly extensively when I initially kind of threw it into the setup. So we're going to get this wired up. It's going to be the same as before, where we have the first and last 2 legs of the LED are for the colors, and then the second pin is ground. And I believe the grounding pin is longer. We'll verify that here once I get the part fished back out. And it looks like we are hooking up the LED 2 pins 11, 10, and 9. So 9, 10, and 11 if we're looking from the bottom. So I'm going to switch over to the other camera. Which is selected at the current moment, but I forgot that I may have closed the shutter on it. Hang on a moment. I will bring some life back to this camera view when I promptly move that out of the way. That's better. Actually being able to see. Okay, we'll bring the music back. And I will bring chat over with me. My little stand. Actually, that's right. I do actually have another arm over here. I could use this instead, actually. I'm going to go and bring you over like that. Alright, cool. Alright, good. Yeah, I got one of those phone mount arm things to try to keep my device so I can see chat and tinker. Make it so I can actually see what the heck I'm doing here. Yeah. So let's see where we are here. Now looking at the diagram, get this piece of furniture out of the way. I'm pretty sure that this is all exactly where it was. We're just going to double check. So, as long as nothing changed, I could plug this in without having to worry about the existing sketch. Now, she mentioned adding some additional code. I'm just going to create a new example and just pull over the blocks like I normally do, because it's been 2 weeks. I would like to review it. And I figured y'all would probably like to see it again too. So that's what we're going to do. The keypad was hooked up to pins 2 through 8. Looking at this. 2 through 8, and then number 12, oddly enough. That's actually weird. No, it looks like, wait, hang on. Am I looking at this wrong? Almost looks like we moved some of the stuff around here. Alright, so we are on pins 1, 2, 3, 4, 5, 6, 7. Or no, pins 2, 3, 4, 5, 6, 7, 8. Yeah, okay, so we did move some stuff around here. It's a good thing I reviewed the diagram, because initially I did this right in order. So, looking at this, the very last pin of the keypad, which is the top, looks like that is denoted as C, 1, 2, 3, 4, 5, 6, 7, 8. C8 on the diagram, which is the white wire on this adapter that I have here, is going to be plugged into pin 13, which is just below ground. So I'm actually going to move the white one from its current home. Here, I'm going to unplug the buzzer, and I'm going to move you from where you are to pin number 13. So by following the diagram, let me get that in with the camera's angle here. I got these in order, and then the keypad I'm moving up to 13, opening up this space, which is where the LEDs are going to end up going, which is fine. I find it interesting that they say that we're reusing the same hardware, but she didn't mention that the pins moved. That's really important, which is also why I wanted to double check the diagram, because that would have been bad. Alright, so it looks like the positive side of the buzzer is going to go into number 12. It's going to be directly below where I relocated the keypad to. So I'm going to go ahead and plug that in, like so. And then that leaves me the 3 open for the LED, which will be in 9, 10, and 11. And if I look at this, I should be plugged to have open spaces for 9, 10, and 11, which I do have that. So let me get out the LED. Now, there's a little bit of a refresher. The color code on our resistors that are in the diagram we're going to use are the 220 ohm ones. So that we are going to do. Once I fish them out here, I believe the little friend here has a total of 1. Yeah, it's 1 RGB LED. Again, it's a little bit of a refresher. This one LED has the capabilities of producing every color on our visual spectrum, because it's got red. I blanked out there. Red, blue, and green. RGB. Duh. Red, green, blue. brain locked up. So if we take a look at this, we will see the grounding prong is actually long. Now, camera isn't the best in focus there, but it kind of gives you the idea. That just indicates that that is going to be the farther leg here of this. I'm going to pick this up and carefully stab this in the board in a row I can easily make out here. So I'm going to use pins 9, 10, 11, and 12. Put that right there. And then I'm going to get us out 3 resistors, because we don't need a resistor for the grounding rail. So there's no worries there. Now, the 220 ohm resistors are denoted with 2 bands of red into black. So I'm going to locate a couple of those. Which most of the open resistors that I have from our multitude of examples here are mostly that, actually. There shouldn't be too much looking through my container here for that. So I got 1, 2, 3. Yes. Oh, cool. All right. Got those in one shot. So I got those right there. And I'm going to take care of that. Don't know why that triggered. Okay, so now that I got that, I'm going to get these hooked up. So purposely I am going to end up skipping over the second one because again that's our ground. So I'm going to hook up pins 9, 11, and 12 to one of these 220 ohm resistors. And I'm just going to get that. And as a reminder, the break in the middle of the board means electrically speaking, this side is separate from this side. So electricity has to pass through the resistor to get to the LED. Yeah. Afternoon, or actually evening, Michael. How you doing this fine cold evening? It's very chilly. At least for me, it's very chilly. I'm gonna be very careful. I apologize, I can't really show this part on camera because it's very difficult for me to see it because they're so bloody tiny. Alright, skipping 10, I'm going to 11. 11. Like so. I will show you where I am putting these in though. And then number 12 goes into number 12. Be careful that they don't touch each other. It's chilly there too, you know, that's fair. That's fair. Okay, now that I got them at least stuck in the board here, we've got the first leg with its 220 ohm resistor, the ground, which is in the middle, which is the number 10, and then 11 and 12. So I'm going to put a black wire to go from 10 to the grounding rail, which is the blue line, and then the other 3 lines to the Arduino in the open spots that I have here where it shows me. So let me fish out a couple of theirs. Let's see, so we got, oh, okay, so those are the 3 I had for the LED last time. And I will use like an off red color for the ground rail. So let me get the ground plugged in, which is number 10. Yeah. So ground goes there. I'm purposely putting it on this side of the board. And then the others I'm going to hook up on this side. Now since this grounding rail up here isn't actually connected to anything, but this side is, I'm just going to plug this into any of these available slots here. So that, I'm just going to make a neighbor of that existing pin, so that is now grounded. So the LED is now grounded, and now it just requires the paths of electricity to be hooked up to the board so we can control it. So that's what I'm going to do with this. And I'm going to very carefully plug these in on the edge of the board so I can make sure I get this right. So I'm going to do gray first. Gray is going to go to number 9. I'm going to skip 10 because that's ground. And then 11 and 12 will be purple and blue. So I am purposely plugging these in on this side of the board so the electricity has to flow through the resistor and then back through the ground. And then this, I just have to hook up to our friend over here. Now I have to make sure I do this right, because you gotta love that. Electrocuting trash. Not so much the user, just funny blinky lights, as far as I'd like to take that. Let me see here now. So now, if I have this oriented correctly, I should just be going straight in order from top to bottom. So it should be, if I do this right, which maybe I will, maybe I won't. Now I have been toying with these a bit, so a couple of them might be bent. So this part might require a little bit of finagling on my part. Just to get everybody in here and plugged in. Yeah, Pac-Man. I mean, in all fairness, Pac-Man, even though it's a very old game, is still a very fun game. I was never particularly good at Pac-Man, though. I was always a fan of the Dig Dug, and what the heck was the other one? You fly around Galactica. You're flying around the spaceship. That one was a bunch of fun. Highly recommend as a retro game is to play some Galactica. This is not going to go nice, is it? So I have to unplug that one, unplug this one, and wedge you in there, and then plug you two back in. Because you're a little bent. That's okay. Okay, I am now going to wire check myself. Yeah, Dig Dug. Michael, are you not familiar with Dig Dug? I mean, in all fairness, it's an old game. It's a fun. You're playing as this little dude with a shovel. Okay, all right, so you are familiar with it. Yeah, and he like wanders around, and he like hooks up his little air compressor, and he pops the enemies by causing them to go pop like a balloon. If it wasn't for the fact that it was like an old school game, thankfully it's not nearly as graphic as that sounds, because that sounds pretty bad. Thankfully it's not, though. All right, so the speaker is in number 12. I did have to move some stuff around here, so I just want to double check myself. And then the button is 13, and then 2 up through, so 2, 3, 4, 5, 6, 7, 8. And then the LED, as long as I got the color order right here, which I think I did. Yeah, it would be from top down, which would be 11, 10, 9. Oh, I see why we did that. Okay, so this goes back to the concept of PWM, which is pulse width modulation. I'm looking at this, and the PWM pins are the ones with the little squiggly lines next to them, and our LED requires 3 PWM inputs, or outputs rather. So pins 10, 11, and 12 all have the squiggle, so we ended up moving one of our keypad pins that doesn't require PWM because it's just a button press, all the way down to 13. That's why they did that. I would have liked if they had mentioned that, but that is why it was that's why it was moved. So I think I have this everything where it needs to go now. Now the results of what would happen when I plug this in are probably going to be different than the previous week's example. So I'm going to just upload an empty sketch once I get it open. So this may or may not make sound. Oh, the LED. Oh, the LED is lit up right now, so that's fun. And I think that's in part because it's trying to move data around. It's that was one of the lines that was for the keypad. So right now, it's moving stuff around, or I moved stuff around. So we're getting some. I'm not going to necessarily say unexpected results, but we're getting results that are not what we need, but that's okay. All right, thank you, Taz. Yes, I wasn't muted. My microphone stopped working. It did that to me before stream started, and I caught it, but I didn't catch it right now. I don't know how much of you didn't hear me, but that, you know, hang on a minute. Let me switch scenes again real quick and see if it bricks the mic. And now I'm on the bench, and the bench has the other, and now I'm gonna switch back to over here, and it's gonna make a liar out of me because I wasn't paying attention. Love that. Oh, thank you for telling me, Taz. Okay, I'm gonna say that again because I don't know how much of that you heard. There's the important notes section that's here that it says that it builds on day 13, and it does actually specify that the pin does move because of the requirement of pulse width modulation, or PWM. So they did actually say it. They just said it in this section, not in the little video with the nice lady. But that's what the little squiggle or the tilde is actually the name of the thing. Comes in handy because that's what's printed on the board to indicate if something is PWM. Because not every port is, and it's interesting because for the ones that do support it, they're not all back to back. A couple of them are spaced out, so that's why the keypad actually moved a leg. But that's fine. So let's see here. It says, if you look at the day 13 diagram, you will see that we use PWM pins for the keypad and buzzer, leaving only one available. Pins 12 and 13 are still available, so we'll move the wires on pins 9 and 10, PWM pins, to 12 and 13. Pin 13 is also used while the Arduino IDE is uploading sketches. And if you connect the buzzer to that pin, you will get noise every time you upload a new sketch. Try it. So the buzzer will now be on pin 12, and the keypad wire on pin 9 will move to pin 13, which we already did. Because we used consonants, we only need to make 2 small changes from the day 13 sketch instead of hunting down and changing each use. And that may be true, but I'm still gonna redo it all anyway. Now I'm curious to see here. It says define the characters, define the pins. Right, note wire moved from day 13. Okay, so they did actually note that incredibly well, which is good. And we got those. Okay, that's bringing over that. This is our loop. I am going to go through this in detail, but I'm just perusing through this because I'm kind of curious to see. Okay, no, they did. They definitely did some more here. This is a much longer sketch. So, all right, let's dig into it. Okay, so like any other sketch that we've done, we need to bring over the libraries required for us to use the board. I've said that at every episode of this, and I'm gonna say it again. You need to include the Arduino library, otherwise you can't interact with the board or any of its pins. So we include that one. The keypad library is required for us to be able to use the keypad we hooked up with the functions that we are going to use. Now, I do specifically say that we have to use the keypad library. We technically don't need to use the keypad library, but that means that we can't use the functions that are included with that library, which means that we would have to actually code everything that has to happen with those keys and what the wires are. The whole point of the library is that someone already pre-wrote the code that we need to interact with the buttons. And then we just have to give the library our requirements of where the keys are, how big the keypad is, and it kind of figures out the rest in the background. So yes, that is why we use that. But you can't get away without using it, but you need to know how to write the code to then, I'm going to refer to it as manually interact with the keypad. I don't know how to, but I sure know how to use the library and follow instructions. So that's what we're going to do. Okay. And then we're going to pull over this stuff. All right, so our keypad has not changed in size, and it's not going to. But this keypad is 4 rows by 4 columns. So that is constant. So we just declare that. This section here is where we determine the length of the pin. A byte can hold a maximum of 255 values. So since the pin length is 4, that fits within 255. And this is not going to change. Our pin is always going to be 4 characters long. So with that, that fits perfectly fine in a byte. If I wanted a pin that was larger than 255 characters in length, first things, that is one honking pin. My God, you'd be there for 12 minutes putting that in. You would need to use a variable larger than the byte type. I would think that we'd probably need to use a double. But the point of using a variable that accommodates for the size we're working with is that we have limited amount of RAM on this board, and not because I took it, Michael, but because this is what's on the board. I saw your comment from earlier. I'm not giving the RAM back. This board doesn't have a lot of it. So yes, that is why we specifically would choose a variable of smaller capacity, because the Tupperware container is smaller. You can't shove as much in it, but if you're not going to overfill the container, that's the size you choose. It's a bit of a dance between choosing the right variable for the data that you're working with. The trouble you get into is if you accept more data than you were anticipating, or you didn't think about a use case that can cause a number to get too big. So I'm going to go on a bit of a tangent here for a minute. I recently saw on the news there was a background picture that was floating around the internet. And it was this beautiful scene of a forest. And if you set that particular picture as the background on your Android smartphone, it would brick the phone. Now, initially people thought it was a virus, but that's not the case. Ironically, it was an issue with the way color RGB codes are handled on Android. If Android runs into a problem, it tries to close the process. I'm glad, Ted, you remember that. I saw it just like a couple of weeks ago. This is crazy. I love how it relates because it's directly related to what we're talking about. And if you set this image as the background on your phone, it crashed the phone. But why did it crash the phone? Android runs into a problem and the process locks up or crashes. What Android will do is it will end the task that has crashed in an effort to recover itself so that the phone doesn't soft brick itself or get into a boot loop. But the problem is that the image that was set was the background. So what would happen is it would try to close the background, which is the operating system, and it would just boot loop itself. You'd be able to get to the lock screen, might be able to put it in the beginning of your pin, and then you would lose it. And the only way to fix it would be to factory reset the phone. Why did this happen? This happened because of the way that that particular image was saved in the format that it was in a very large color profile. And Android uses RGB calculation, red, green, blue, and the maximum value of blue and green and red is 255 as a whole in the calculation. Well, when that image was set, there was 1 pixel in like the middle of the picture. I think it was in the skybox somewhere in the picture. That 1 pixel caused the calculation to buffer overflow and try to shove 256 into a variable that was only capable of storing 255, to which then caused the process to crash because it was trying to write out of bounds of the variable, which is bad. You don't want to write outside your variable. That causes all sorts of badness because you're trying to use memory that may have been allocated for something else. That causes all sorts of problems in computers, which is why the phone did one of these. It broke in fantastic fashion. Now, this is something that I know that they were mentioning that it was going to be patched or may already be patched in the latest release of Android, but I don't know if they're going to fix the currently broken phones. this is not rocket science that we're doing here. We're playing with some fairly basic integrated circuits. But you can see that something that is simple and fundamental is just counting 1 over the variable container. You can see how big of a problem it can make. Because in our example, we just make the board not necessarily run correctly. We can push new code to it, and it's, well, fixed. On a smartphone that you have all your data on, and, well, frankly, your life in a lot of cases, since we use them for so much anymore, it tends to be a little bit more important that you get it right the first time. So, yeah. Yeah, that was interesting. But that's why it's incredibly important that we store the correct amount in each variable. Because if you shove too much into the box, the cats are going to spill onto the floor. And then they're going to go running away. Okay, what else are we doing here? We are then defining the keypad, which is fine. Okay, so brief overview, again with the keypad thing. This is the layout of our keypad. So if I click the first button in the first row, I get a number 1. If I hit the 4th button in the last row, I get the letter D. This keypad could be custom to whatever we want. This is just the layout that they provided us, and I don't have a reason to change it. So that is why that is that way. That gives meaning to the buttons. Now, there are keypads online that you could purchase that actually have this exact layout on them. Ours are just the black capped buttons. So we won't see that, but that's just a visual representation of what the buttons are in the space of the keypad when we click them. At some point, I probably should print that onto something and have it by the board. I don't know, if we... I probably could. Should I? I wonder how poorly that would go. I'm half tempted to just try to print it right now. Kind of would like to have that. Boop. Ha! All right, printed it. Give me a second. Okay. Lo and behold, we now have a visual representation of the keypad, which is good. So then when I'm holding said keypad, I actually know what the heck is on each of these. So we're going to keep that here nice and handy dandy on the keypad, on the keyboard there. So when I go to click stuff, I don't have to look again at the code. Boop. All right, cool. Okay, so we got that. And then this is where we're going to define our pins. Okay. Ooh, I accidentally moved a comment. I didn't mean to do that. Hang on a minute, let me back up. There we go. All right, so that's where I meant to go. And then pin length is 4. So we're picking up from pin length is 4. So then we're gonna grab all of this. From here. Okay. You're not late. It's a stream. There is no late. You arrived when you meant to arrive. I'm not repeating that from anybody. You can't prove anything. All right, let's see here. Alrighty, so we have defined our pins, which we did move. We could see here that the row pins are pins 5, 4, 3, and 2, and the column pins are 6, 7, 8, and 13, which I did move on the breadboard. Or on the hero board, rather. And then we are creating our keypad, what the lovely and sophisticated name Hero Keypad. That just gives the object a name that's friendly, that lets us know what the heck it's called. And then from there, we map our buttons, which are this array up here, to our pins. I'm not going to go hard on that. That's just what it is. And then we have our existing pin, which is super duper secure at 4 zeros. Don't tell nobody. Oop, I moved that. Technically, I'm going to move that back. This is technically supposed to be up top. You're supposed to be up here. Oh, look at that. Pin length, initial. Oh, yeah, I accidentally copied that twice. That's a good thing I took that out of there. Okay. Now this is the part where we're really going to be checking my work, because these are the other pins that I did hook up. The buzzer pin, which is on 12. It says, note that the pin 12 drives the buzzer now, which we did move. And then 9, 10, and 11 are the PWM pins, pulse width modulation, for the red, green, and blue legs of our multicolored LED. So we declare them, and we got all that going, which is lovely. Okay. Now in our setup, we're going to pull this stuff over. The setup is the code that is run only once during the execution. Everything after that happens in the loop, which is why we would only ever declare our pin mode in the setup, because we're only ever going to set up the pin mode once in these examples. So we've got red, green, blue, which is what we have up here, indicating that they're outputs, which makes sense because this is an LED. We are going to be controlling the brightness and the pulses, because pulse width modulation is fantastic, and that's how we control this bloody thing, which is fancy. And then we initially start with a color of red. Now this is red at like half brightness, because 256 is maximum brightness. We're at 128, so well, I guess that's technically half, right? 255 divided by 2. All right, 127 and a half is technically half, and we're at 128, so it's rounded up a little bit, but it's approximately half brightness. And the other two are green and blue, so obviously we don't need those lit up to display red. We need red to display red. Shocking, I know. And then we fire up the serial monitor so we can see what's going on down here behind my head. And I will scoot that over a bit once I get to that point. Now, I know at one point or another we are going to be messing with displays. Hopefully in the days to come. So what we see in the serial monitor we'll be able to see on that cool little display too. Because again, it's technically two different displays. I am looking forward to using them because I already have a project in mind that I want to use them for, but that will come later. The whole point of me getting into this is to also do my own stuff, so learning along the way is a pretty big deal. All right, so now we're getting into the meat and potatoes of our loop here. Alright, first things first in our loop is going to be capturing the keypad press. So this wait command is basically what it is. It says here, hero keypad.getKey. The code will not continue until something is pressed on the keypad. Once something is pressed, then the code will continue. This is an indefinite hold on this loop with the way that it is written, because there is nothing to conditionalize this. It can't look for something else to happen. If I wanted for the code to do something else when there's no button input, or to check for a sensor input of some kind, like say that you had in the room a motion sensor and you had that hooked up to this board and you wanted the keypad to say light up, right? This keypad doesn't have that function, but just stay with me here. You want lights around the keypad to light up when you got close. With the fact that this get key is at the top of the loop and it's not conditional, means nothing that I write below it would run. Or if I ran it above it, it would run and then stop at the get keypad. So if I told initially the LEDs that are around the keypad that are currently not hooked up, because this is a running example, were to light up and then fade out if there was no input, well, it's just going to sit here hung. And that's not because of a syntax error, that's a logical error. If I wanted the code to continue to loop while waiting for input, well, then I need to write the code to be able to do that. Which should be easy enough by just taking this statement and wrapping it in some kind of if statement looking for another parameter. I'm not going to, because I'm not looking to make this more complicated, but I just want you to understand that if this is at the top of here and there's nothing to conditionalize this, this is going to make everything else stop. Nothing else will happen until something was clicked physically on the little button pad. They do say here that wait for a button press. They do say it. It's just they don't really force that. I find that there should be some additional emphasis on that. Anything that makes the code wait, whether that's a hard-coded wait statement like wait 300 seconds, or something that's waiting for input, stops the execution of the code. Nothing else happens until it proceeds. So if you want something else to be happening in the background, you need to write it like that. Okay. Let's see here. Next block of tidbits. All right, let's see here. So it says the pound symbol unlocks our console. So we have an if statement here that says if button character is equal to the pound symbol. Some of you refer to it as the hashtag. I'm going to refer to it as the pound symbol because old school. That is the button to access the system. So if that was the case, then we are going to run the function. You haven't written it yet. Give input feedback. So someone clicked the button. We then read the button character that we stored up here when someone clicked it. We're then going to run this function of get input feedback, which is going to run lower in the code, and then we're going to come back up here and proceed. Which then the next thing is asking us to validate our pin, which is another function we're going to run. Hi, Dragonus! Tic-tac-toe. Okay, I see it now. That did not immediately register on this toaster's brain. I'm about 5 seconds behind on everything I say out loud. It's amazing how I can manage to stay on top of things. Oh, welcome on in, Dragonus. I am nerding out in fantastic fashion. We're adding color to our keypad. Let's see here. So, yes. So, right now, ironically, I actually don't think this will compile if I verify it because I haven't written the function yet. Yeah, no, it's bad. That's bad. But that's intentional, right? Because I haven't written the function yet. So of course it can't do anything. Ooh, what about the... I did not declare display color. All right, well, I'll cycle back to that. Boop. You see nothing. I'm hiding the errors for now because I'm not done. All right, so... Right, so we're going to run our thing to validate pin, which is going to need to be another function. And then, yeah, I'll get back to you. Whether our variable, which is declared here as a bool, which means true or false, We will then check if it came back as true or false. Now, I briefly mentioned this last time, or maybe in depth, I kind of don't remember. If an if statement is declared like this, where you just slap a variable instead of a set of parentheses, there's two things. This says if allow underscore access, and then the first thing it does, else access denied. So if you have a Boolean like this and you just throw it in an if statement, this by default means if true, do the first thing, else it's considered false, run the false stuff. But it doesn't say that here anywhere. This does not say if true, run this, or if else false, run this stuff. This is assumed because this is a Boolean statement in here. If I passed another kind of variable that was not a Boolean, in some programming languages it would treat it as a Boolean. So if there was something existing inside of the variable, regardless of whether it was true or false, if you had the word broccoli stored inside of the variable, broccoli is not null, so it's true. Broccoli is true. So you got to be careful with the way that you write your if statements so that they make sense to you. This makes sense to me because I know that this variable, allow access, can only either be true or false. It can't be anything else. The door can't be half open, right? That doesn't make sense in the way that we wrote the code and our meaning we assigned to it. There's Booleans in Unity too. Hell yeah. Yeah, aren't the Booleans tied to like constraints inside of Unity? I'm glad you're learning. I'm learning too. We're learning this together. Blah, 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 blah. But yeah, so it's either going to be true or false. And so this, by default, that means that if it was true, well then, yeah, welcome. Congratulations, you're here. You have a great time. Otherwise, access is denied, and then we tell it to then press the star key to enter. Wait a minute. What? Access allowed is serial input welcome authorized user. You now begin using the system, else. Access is denied. On a new line, press star to enter new pin. Oh, or pound to access the system. Okay, I misunderstood that. I'm like, wait a minute. If we just denied them access, why are we allowing them to change the pin? My brain didn't read that right. Good times. All right, let me grab the next chunk of code here. Okay, so another thing too you'll notice is that this is written in blocks of code, which is why I'm pulling it over in blocks, making sure I don't miss any of the semicolons or closing braces, because otherwise the code won't run. Now, in my mind, if I'm writing something that is accepting a list of different potential options, I'm not going to use if statements. I would use what's called a switching statement, which it would say switch, and then you would just list all of the options and then what you want to do based on that, which I'm surprised they haven't made us do that yet. I'm going to be curious to see if the switch style exists inside of here. It's just another way to write what we're doing now. But in my mind, a switch and then listing every possible keypad click and then what action you wanted it to take makes more sense to me. Now, granted, we're not listing every option here because we don't need to. We don't need to take action on every single button press other than just capturing it, like if we're trying to type in the pin to unlock the keypad, for example. These are just the actions that allow us to, well, take action if the appropriate button is clicked. I don't know. I would still prefer these be switching statements instead of if statements, but for now, we will proceed. So if the star key, allows the user to enter a new pin after entering the current pin for security purposes. So if it's pound, give feedback input, which says right here, a short beep with the blue light, because we're going to involve the LED now to indicate that we're getting some visual feedback. And then There's something interesting here. Give input feedback. And the one up here was give input feedback. Oh, that's strange. They called it a short beep with blue light. I didn't catch that. I thought that was the buzzer earlier. I misread that. I wouldn't call that a beep because it doesn't make sound. I would say a short blink more than anything. Nor here nor there, I suppose. And then we validate the pin if it's correct. Oop, I did not grab all of that if statement. Or did I? Interesting. So if access allowed, we display yellow, which is a little bit of red and a little bit of green, when entering the new pin, to indicating we're in pin changing mode, which is actually nice. That's good to see. And then it says, welcome authorized user, please enter a new password. Now that if statement opened here, and I did not close that paren yet, so let me actually take a look here. Okay, this is the rest of the code from that block. They spaced this kind of funny. There we go. And then if I were to collapse that if statement, that includes all the code I pasted over. Yep, okay, good. That's one thing I like about these visual terminals, is they give you the ability to mark lines usually by clicking in between them. Which, oh yeah, this one does do that. I can mark a line by clicking it and that'll leave a dot. So if I'm scrolling up and down in my code, I can get back to visually what line I was on without having to remember what number I'm on. Or you can collapse sections based on the chunks of code. That's why if you forget a curly brace, which is what these things have, it's a pretty quick visual indicator because you can't collapse the code. Like, wait a minute, I'm missing something. All right, let me see where we're at here. Okay, so we are now displaying the color yellow. Now, at no point does this stop, because once you run the code to display a color, there's nothing to turn that back off without actually telling the LED to stop illuminating. So this will display the color, but then it will stay that color until we either tell it to stop displaying that color or change it. So the entire time we're putting in our pin, we should just see a yellow coming from the LED. And then this we've seen from before. It says here that we're going to run a for loop, which means I equals 0 is a counter, right? So the variable is just the letter I. Counters inside of most programming languages will just be an individual digit most of the times. It's just how people tend to denote it. And then while the pin, as the loop indicator, which is letter I here, is less than the length of the pin, which we remember from up at the top is 4 digits long, 1, 2, 3, 4, right? We will loop this 4 times to catch all the key presses for our pin. And then from here, we then get our password, and we store each of the results in its own variable. Its own place in our password variable. So this is referred to as an array, right? And this password array is a total of 4 units long: 0, 1, 2, and 3. I want to open up real quick here Paint, because I think I've talked about arrays on this channel a few times, but I would like to visually represent this for a minute. So we have the password, Oh, it would help if I drag that across. Nope, did it again. I'm going to explain myself in a second, hold on. 1, 2, 3, 4 different positions. Okay. Let's add extra spaces in these so I can actually doodle in them. Okay, so I'm being raided. Oh my word. Hound, oh my word. Continuing the sad raid? Why is the raid sad? I will do my best to take care of the beans. Hello, hello. Oh, we got lots of raiders. Hound, I want you to tell me, what were you doing? What were you doing? I need to know this. I also want to know if there's a certain hedgie involved. Thank you for doing this shout out. You read my mind. Well, Raiders, I'm TechHead41, for those of you who don't know me, and I do stuff and things on the internet. I talk about technology, and today we're playing with a developmental board known as a hero board with the 30 Days Lost in Space kit. Got raided by Cashew with a sad cat raid. Oh no! Oh no! Oh, Cashew, those eyes are just... You could just clear a room with them. Oh my word. Oh my word. Okay, alright. Oh, hi Blaze! Hey, I hope you're doing good. Yeah, it has been a hot minute. Yes, this is my channel where I talk about technology. I do a bunch of other goofy things. Thank you for the follow. I'm silly, and I appreciate you sticking around. But oh yes, to complete my thought, I do technology and I play retro games, and I alternate them between doing technology things and playing the retro games because I kind of like having this space to be something that anybody could stop by. The technology does, I'm going to not lie to you, goes a bit in depth. I try to explain this stuff in a way that is easy to understand. Some of these topics are pretty rough though. But I'd like to mix in the retro games because that's something that's more chill and anybody can stop in and just hang out, you know? So that's kind of what I've been doing. It's been a good time otherwise. Oh yeah, by all means, Hound, enjoy the lurk. Try the lurk command. It's exclamation mark lurk. Hopefully it works. I've unbroken that many times. And it still breaks. Yeah, it works. All right, cool. It constantly breaks on me. It drives me nuts. Like my microphone that broke multiple times during this stream, which is fun. All right, let me see here. Blah, 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 blah. Ha! All right. I'll pick up where I left off here. Okay, so the password. This code is kind of funky. I'm glad that's the case, Cyberlord. It's good, Blaze. Let me see here. Yes, so in our loop here of code, we have the letter I, which means on each iteration of this, it's going to run 4 times, 0 through 3, because we start at 0. That's how code is. And it's going to fill each of these on each iteration. So let me grab a marker here. We've got position 0, 1, 2, and 3, right? To visualize this. And then let's say that we're going to slap in our 4-digit pin of, I'm going to pick something random here. 5, 3, 1, and a 7, right? So if I were to type in the terminal that I wanted to read password square brackets 0, that's going to return to me the number 5, because that's in the first position, index 0, because in loops we count in arrays start at 0. It's very easy to get lost and to forget that. So you also have to be careful when you're reading through array variables, because they have multiple slots to hold things. But the nice thing is that you can read this entire pin and it's not one thing stuck together. It's each individual digit in its own slot. So picture yourself one of those pieces of Tupperware container that has multiple dividers in it. You could tell it that I want what's in the upper right hand corner of the Tupperware container and grab just that out. If I stored the 4-digit pin in just a standard byte, well, then I would go into the variable and all 4 numbers would be stuck together. In a variable that's an array, it's divided. So I can grab out the individual pieces. Now, obviously I wouldn't want to rearrange the pin. We wouldn't do that, right? But with this, in theory, if I wanted to change just 1 digit of the pin with the code, well, I already have the pin set up in 4 separate containers. So all I would have to do is update that one container, the one sub container in the major container, which is the variable. So if I said I want password position 2, then I'll get a number 1. Or if I have password position 3, I get the number 7. So on and so forth. Where it gets kind of crazy is when variables have multiple dimensions. This is a 1-dimensional array. A 2-dimensional array is what we have with our keypad. For those of you that are just joining us, that would be our keypad layout up here. This is 2-dimensional because we have rows and columns. You can have many dimensions to an array. I want you to understand something. It gets fairly complicated when that happens. If you think you're going to get lost, don't worry. We can get lost together in the forest, because that's usually what ends up happening. But without getting too lost, I wanted to note that, because with the way that this loops, you technically have 4 different variables you're setting with one statement by the way this is written. So simply put, it runs through all this, right? And it says here, if the index, which is that letter I, is less than the pin length, which in this case is 4, minus 1, that gives us 3, right? Because 4 minus 1 is 3. Shocking, I know. We are going to run the function called give input feedback. Now, I haven't written that function yet because the way that they do functions in this language, well, not really the language, in this example, you can put functions at the top or the bottom of your code or somewhere in between. I always like to either stick them at the top or the bottom. It makes things more legible, more readable when you're looking for something. And a function is very, very basic. It's just a block of code that you can call to run multiple times. So if you had a function to get a banana from the fridge, you could run that 17 times, and the terminal will go to the fridge and grab a banana out 17 times flawlessly. That's just what it's going to do, because that's what the function was written to do. But if you need to run code more than once, consider writing a function, because you could just run one line of code, which is what this is. Give input feedback. That's a call to a function, and then it just runs that. And then the beauty of it is that if you have to update what that function does, say that you go to the fridge and grab the banana out, but then you have to grab the ice cream from the freezer, well, then you can just modify the function to include that if you wanted that to all be in the same functional space. Instead of having to update it 7 times, because you had to run it 7 times, you just update it once, and then you just run it 7 times without having to update anything else. Oh, you've looked at Python. Okay. Yeah. The snake branded programming language. Python's okay. This is, I believe this is written in C#, I think. I know this is the Arduino IDE. I want to say it's written in C#. I'm not sure offhand though. Don't quote me on that. I'm not entirely sure. It's definitely based on C. It's either C# or C++, because it's object oriented in its own sense. Without going too hard into that. What do we got here? Okay, so when the pin is basically when we're at the end of the pin, we're overriding the color. And we are mixing red and green. So that's an overriding color, which is yellow. Wonder why we're overriding that. We're just displaying more yellow. Weird. Okay. And then for each loop, well, the pin is less than the pin length. Oh, okay. So that's going to run 3 times and it's going to stay yellow for each of the key presses. So we're actually telling it that on purpose, which is fine. I don't really see why. And then each time we click a key, we're not going to obviously see the key on the screen, or in this case, the serial monitor, which is behind my fluffy head. We're going to see the star symbol on the screen, which again, I'll move the terminal so you can see it. Okay, so then we're gonna grab our next block of stuff here. Bring that over. Okay, so let's see here. So we're gonna add a new line after the last asterisk is printed. So that loop that I brought over ends there, right? So once the loop runs 4 times, the code's going to continue downwards. And we're going to have a new blank line, which is just print line and nothing. And then on a new line, again, it's going to say that we successfully changed the pin. We're then going to run the function called give success feedback, ta-da sound, and green light for successful pin change. Now that's just a note of what that function is supposed to do. So when we're looking back through the code, we know what it's supposed to be for. We haven't written it yet, which is why it doesn't look like it does anything, because right now it doesn't. And then else, after the run of changing the pin here, it would say access denied, cannot change pin without entering the current pin first. A tuple and an array. Not mistaken, a tuple was a list of form of a string, I believe. Now the way I understood that is that tuples were an item within a database, I thought. We're gonna look. A tuple or tuple is a finite ordered list of items or elements. They're used in many fields, including mathematics, computer programming, and databases. All right, see, look at that. So I wasn't making stuff up. I thought that's where I saw it, but obviously that's a more broad. That is more of a broad concept because it could be used in a variety of places. See, if it's finite, then that would make me think of a tuple would also be a referred to as a dictionary array as well, actually, because dictionary arrays generally don't change. They usually just kind of do the dictionary thing. Okay, and then we're going to proceed on here. Okay, let's see what else we got here. So then we basically started over. So either we hit the star key and went through the process of changing the pin, or we didn't, which means all the code above this subsection here didn't run yet. Or it looked at it and went, oh, I don't need it. And then that means that, yeah, if I were to collapse the section here about changing, right there, which means we've just jumped from the welcome authorized user, and then, oh yeah, because we hit the pound. So we either hit pound, we give the feedback of the blue light, bloop, we validate the pin, and then we're either successful or we're not. We change it, and then after we've changed it, we actually have the ability to run through this a second time. Interesting. All right. So let's see what this is about here. All right, so we try to validate the pin, enter the pin, and return false for a bad pin or true for a good pin, which makes sense because we're trying to validate to access the system. Let's see here. So we've got the message just displayed to the screen, serial print line. So on a new line, so the LN is just like hitting the enter key on your keyboard. It starts a new line. Bloop, we go down one. And then enter pin to continue. So which then we then run through our loop to accept 4 clicks of the keypad, right? Because we start at 0, and then we run for the length of the pin, and then we increment for each loop. So we run a total of 4 times, 0, 1, 2, and 3. And then if the password, right? Now remember how we stored the password up above when we changed it? That letter I comes back again because our password is 4 units long. Index 0, 1, 2, and 3. We're reading it back the same way by using that loop to run through the code 4 times. Now, don't get me wrong. If you wanted to, you could run this code 4 times and hard code the number 0 through 3 in the password field, but that makes the code longer and more difficult to troubleshoot than just looping. If you have to run code more than once, don't copy and paste it multiple times. Make a loop, because then you can run through it as many times as you need to. And more importantly, if you have to update it or you want to change it, you update it or change it in one place, not multiple times. There being 2 different things appear but similar. Oh, I read that already. I'm messing around with the dictionaries. Yeah, like using the key system that gave me. Yeah, no, I gather that. That's the dictionaries, and it's interesting with the way you could store data, because a lot of them do actually seem fairly similar, but it's just the use case. I mean, let's face it, we've gotten really good at tricking a rock to think, because that's what a processor is. It's a hunk of rock that we made think. So a lot of what coding is you stitching your meaning of what you want your code to do to the application, because the application doesn't care what it's doing. It's just doing what you told it to do in the instruction set, which is what we're typing right now. Which is why I like comments, because the comments are for us, the, toasters in the room that have to run it, and more importantly, read it if we have to troubleshoot it. So I always like meaningful variables if space allows. All right, so we give feedback if the password is not. So exclamation mark equal symbol is the opposite of true. So if the password is not equal to the button I clicked in the appropriate index. So over here, right? In position 0, I used a 5, right? We're going to use this pin, by the way. 5317, that looks good. That's a good random pin to play with. In our code, in position 0, me typing the 5, right? If I click something other than 5 when I'm looking at position 0, which is the first position, because we started 0. I know. I know it's confusing. We'll then we run the function called give error feedback. So we get an icky sound and a red light. And then we say on a new line, below it, wrong pin digit. And then it says button character. So it actually shows us in the terminal, or if we had a display connected, the actual incorrect key, which I think is probably a fairly bad idea. But I'm not going to knock the example. I would think that I wouldn't think you'd want to show someone which key they typed if it was incorrect. You should just have to start over, especially if someone was looking over your shoulder while you were trying to put this key in. Now, since this is the function for validating the pin, I forgot to mention that up here. This is going to return one of two things. It's going to return true, or it's going to return false. So we can see here that if at any point an incorrect button is pressed, so either in position 0, 1, 2, or 3, it ends the function by returning false immediately. If I didn't immediately have a return, I could allow the user to incorrectly enter a button somewhere along the way and then wait for them to finish typing the 4 keys and then return false. But the way this is originally written, it doesn't do that. It just immediately stops if you type the wrong key, or the wrong button on the keypad rather. So as long as you don't type the incorrect key character at the position, it ignores this block of code. That doesn't run. It says give normal input feedback for all but the last character here. So if the counter is less than the pin minus 1, right? So that's positions 0 through 3. We give input feedback, which will run the block of code we haven't got to just yet. That gives us a short beep and a blue light, and then the star symbol. Now there's more to this function that I did not copy over, and that is more important. What happens if it's true? This is the rest of that function. I meant to grab that all in one copy, but the spacing made me skip it. So the loop finishes. There wasn't any incorrect keys, so we didn't immediately return false. So then we give successful feedback that the pin matched ta-da sound with a green LED blink, which is what the give success feedback is. We're going to build these functions, but as you can see through the code here, it's saving this space because we're calling on these more than once. We then on a new line say the device is successfully unlocked. And most importantly, the function returns true, which means you typed the right 4-digit number. So then when the code runs, it goes, oh, you did get it right. It doesn't need to know the pin. It doesn't have the pin. It just simply says you did this correctly. And then the function ends. So the function lives inside of this block of code between here and here. Right? So this block of code could run as many times as you need to validate the pin, and you only have to write it once. And the way you do that is just by calling the name. And then you could store the return by just giving it the variable to slap it into, essentially. You just shove it in the box. I'm gonna save you for later. Boop! Slide that into the wall. Since we're on the part of writing the functions, though, I think we're actually near the bottom of this example. Yeah, we're almost there. Then we get to run it, and more importantly, debug it if I miss something. Okay, so let's see. This is actually a fairly small function for doing the color stuff. So this function is called display color. That is a color provided by red, green, and blue intensities between 0 and 255, which is the maximum capacity of a byte type variable, which is why you will see that what we're accepting are 3 byte variables. 1 byte there, 2 byte there, and that little nibble right there, that last byte. Fun fact, 2 bytes equal a nibble, and 2 bits equal a nibble, and 2 nibbles equals a byte. Yes, that is real computer terminology. It's silly, and there's about 2 million nibbles, if I remember correctly, in a gig. So yes, we are running around chewing on things. It's one of my favorite fun facts because no one uses those in the space of computer terminology anymore because everybody stores stuff too big. No one needs those anymore. All right, so then what we do is we get the value from the user, and then we put those values out on the pins. So we call the pin, the red pin, which is pin 11. We set it to an intensity of between 0 and 255 that we accepted earlier in the code. And we do that on all 3 pins. Had some fun with coding in the past, but didn't really have any direction, so it didn't go far. I understand that. Also knowing software engineering industry insider from a family member did not make me want to pursue a career with it. Very intimidating. I'm not going to lie to you. This stuff is not necessarily what one would consider easy, but the stuff that's rewarding isn't always easy. It's usually quite the opposite. So by all means, it's never too late to pick it up as a hobby. That's what I'm doing. I've always been fascinated in this kind of stuff, but to actually take the time to sit down and really learn this, I never really did. I had a pretty decent understanding of what all the individual components did at the absolute basic level. Like, I didn't know what microcontrollers did per se, but like I knew what a resistor did. I knew what a capacitor did. I had an understanding of what a rectifier was, what diodes do, things like that. But to actually take those individual components and make something with them, I want to make something with them. That's the whole reason I got this kit and put this up on stream, is because A, I think it's kind of cool, and 2, I figured you guys might think so too. It allows you to bridge that gap between that device you use in your hand all day long and in an appreciation of what happens in the background. Because I can't make a cell phone, but I can use one. And that's in part because it was made by someone who has a pretty decent understanding of how the electronics work. Or here nor there. I think it's cool. Let's see here. Both the PWM functions and tone functions use some of the same hero hardware for their functions. If the RGB LED is on while a tone is played, it will flicker or display other colors. Because of this, we turn off the LED while a tone is being played and restored it immediately afterwards. Oh, you got whacked by an ad. Oof. What was I saying? Oh yes, the appreciation for the fact that we use this stuff every day, and it's never too late to pick this up as a hobby though. This 30 Days Lost in Space kit you could just buy online. I think I spent about $70 on it, and it gave me everything we're working on today, and for the last several of streams. But yeah, I like this. Interesting though. So for the PWM functions and tone, use some of the same hero hardware for their functions. If the RGB LED is on when a tone is played, it will flicker or display another color. That's interesting. So the PWM functions and tone. Hang on, let me scroll back up here to take a look at the diagram for a second. So the speaker is on pin 12, or 13 rather. Wait, hang on, where'd that wire go? 12. So the speaker's on 12, and the LEDs are on 9, 10, and 11, which are PWM. But pin 12 is not PWM, because it doesn't have the little squiggle symbol. Interesting. I'm surprised that we have to turn it off or we'll get weird results. Huh. Okay. Nah, that's completely fair, Cyberlord. It's not easy. It's not easy sometimes. I find myself personally that sometimes if I don't feel like I'm in the mood to play with the coding terminal, that if I just tell myself to do it anyway, within the next 15 minutes, I kind of get into the rhythm, and I kind of wonder why I didn't want to do it in the first place. Firefox a little. Why, thank you for the follow. Welcome in. Yes, this is the goober from the cafe. And you are another one of our goobers. It's fantastic. Ah, fair. Well, it's a good place. I mean, it's one of those things that it's just harnessing that in running with it. Because I know I find days where I don't want to pick this up, especially if I'm overwhelmed or I'm just tired from the day. Life gets in the way sometimes, but it's the fact of picking it back up though when you feel like you're ready, and more importantly, not letting it just fall into the shadows where you just never touch it again. I've done that with a lot of things, but I've gotten better. Practice is a big part of that though, and how you yourself function. I know I function differently than other folks, and that's okay. It's what makes us individual. It's what makes us human. Little dancing mode, that's adorable. Yeah, Firefox a little. Hello, welcome in. All right, so we have our function here of give input feedback, which we're going to run a bunch of times here. We're going to turn off the display briefly, turn off LED while playing the tone, and then buzz the frequency and then the time. If I didn't provide a time as the second item here, then it would just make that sound forever. It would never stop. We're going to delay for 200 seconds, 200 milliseconds, excuse me. And then restore the blue LED for input feedback, interestingly enough. And then we're going to grab the next one here. Nope. Oh, nope. I entered in an extra thing that doesn't belong there. Well, Blaze, I'd have to say the most important thing from that is just to take care of yourself. The Tada thing, yes. Yeah, interest shift. Boy, I feel that. my backlog of half-started hobbies can definitely feel that. Let's see here. All right, so the give success feedback function, which again turns off the LED and then plays a 300 hertz or whatever to the buzzer for, actually here, let me hover over that, make sure I'm saying this right. Yeah, frequency and duration. So it's a 300 frequency with a duration of 200 milliseconds. And then delaying for 200. Delay while tone is playing because tone returns immediately. Oh, so without the delay, really? That's strange. Because we're indicating the delay here, or are we not? We're not indicating the delay there. Weird. Okay, that's fine. And then we then buzz at a different frequency, delay for 500 milliseconds, and then display green, which is the center at half brightness, approximately speaking. And then there's one more we gotta grab. which is the give feedback. Now you have to be careful here. That I don't accidentally grab. This looks like it's missing a Oh wait, these were put outside of the loop, weren't they? I must have missed that. Yep, that was the end of the loop right there. Okay, that's fine. I can fix that. I'm just gonna put this in and I'll move all the functions down outside of the loop. That's my bad. I should have recognized that. You don't put functions in the loop. They don't belong there. So I'll have to move that. Jack of all trades. Hey, there's nothing wrong with getting familiar with lots of different stuff. It's a good part of how we learn. I look at it this way. I'm not a truck driver, but I've done my research of understanding how to actually move one of those very large vehicles. I don't plan on moving one, but if an emergency appeared and I needed to, I think I have enough confidence that I would actually be able to do so if was so required at the time. That's the validate pin function. So this goes underneath here. Which, one of the things I actually learned when I was like looking into that was that you have to clutch to neutral, clutch to gear. That's the phrasing behind it. You also have to rev match. You can't just change gears at any RPM. You have to actually have the vehicle at the right RPM to shift into the appropriate gear. Not to mention there's the little flippy thingy on the shifter to be able to switch between the first gear set and the second gear set. Which, funny enough, you could flip that mid position, but then when you go to shift again, you either could be taking yourself from a really high gear to a really low gear and vice versa. Which is probably not the best thing for the transmission. But I don't do that for a living. It's something with the way that the clutch behaves with the transmission. And the other thing too is that allows you to have a standard H position on the shifter, while also having more gears than just a standard 6-speed. It gives you up to 12, I think. Assuming with a gated reverse, I think. I don't know, it's a little... Every truck's a little different in that regard, but I'm speaking a little bit outside of my own comfort zone there. Because the whole thing is that you can't just clutch from like first gear and then go straight to second. You have to clutch from first to neutral, release clutch, input clutch again, and then go to gear. So if I wanted to go from first to second, it's first, clutch, neutral, release clutch, clutch again, second, release clutch. Which is also why you might notice that trucks don't move very fast from a stop. That's a good part as to why. It's not because they don't want to go. It's because of A, they're very heavy, and B, there's a lot more involved with the actual clutching and switching of gears to actually make the truck move forward. So please give a lot of time and patience to those that drive those very large vehicles on the road. Moving around a lot of stuff that we all use every single day, and giving them the understanding to be able to do their job makes the world a better place for everybody. Alright. I don't know if everything's in the right place. No, it's not. I'm missing a curly brace somewhere, and to be completely honest with you, I've kind of jumped back and forth a few times here, so I'm actually just going to grab this with all the comments. Alright, minus the block of comments up there. I brought it over in chunks, but to be honest, I kind of got lost in my own copy and paste here, so I'm just gonna do that. So that it verifies. Yep. Oh, I didn't grab the includes. Yeah, I kind of need those. There we go. Okay, sketch compiles now. I don't want to have to spend the next 10 minutes trying to figure out what I didn't copy where, when I could just pull over a whole example over. I still like bringing it over in chunks. I feel like that makes this a little easier and more piecemeal to try to present than just scrolling through a giant block of code. Okay, so I've verified the code by pulling it all over. I am now going to send the code to the board by clicking the upload button. It's building the sketch, it's indexing, it's beeping, it's booping. Okay. So I'm going to present this twice. I'm going to show you the terminal view, and then I'm going to go through it again and show you the LED as well, from the point of view of the camera. Because right now the LED is red. Which I say LED, but I'm referring to that one right there. And then access the system. We click the pound symbol. There we go. All right, so I am now going to use that nifty little piece of paper I printed out. Yeah, which one of these is that? Pound is going to be that key. Okay, so the LED turned blue, and I have to enter the pin. The pin is defaulted to all zeros. So I'm going to enter 0, 0, 0, 0. And I played the happy little tune, and the LED is now green. And it says, device successfully unlocked. Welcome, authorized user. You may now begin using the system. Now, I'm going to reset the board. And then that's going to put me back in a ready state. And then I'm going to switch us back to the bench so you guys can see from that perspective what I just did. So I'm going to do it again. So I'm going to use my nifty little piece of paper, which indicates to me what the buttons are in their position. Because on the physical keypad, I have nothing. I have S numbers, switch 1, 2, 3, and 4, but there's no meaning to any of these buttons. We just have the keys themselves. So in the code, as I had mentioned, we gave it meaning, which is what this is. So I'm going to click the pound to log into the system, which changes the LED from red to blue. I'm going to put in the 4-digit pin of all zeros. 0, 0, 0, 0. There's the happy sound and the green LED. I'm going to reset the board, then we're going to change the pin. Now to reset it, I can either unplug the cable or I can just hit the little button, which is what I did. So that restarted the code. And then you get it into programming mode. We said yellow was going to be the appropriate color for programming. So we got to click the star key, which is lower right-hand corner. And I'm going to enter a pin to continue. So, I forgot what pin I said I was going to use. So let me look back at my device. Because I forgot. I forgot what I was going to use. I'm going to use 5317. And I'm going to write that down, which is something I would not normally do if I was actually going to use this for realsies. That's generally not a good idea to write your your password to unlock the system on the piece of paper. You know, that's probably not a good idea. But this is what we call a running example. So it's okay in this case. But otherwise, yeah, don't do that. Don't do that. This is not a video game. don't leave notes for the protagonist to wander through and unlock your stuff. But I digress. I need 5. Oh, wait a minute. I had to put in... That's right. I forgot. You have to put in the existing pin first. It's only because I wrote the code that I knew that. All right. Programming. And then 40000. Okay. So now we're in yellow, which is the programming mode, which is the mode I meant to put myself in. But I was a goober, and I didn't do it right. So we're now in pin set mode. Sticky note. No, we're not doing that. The pin. I'm shredding this piece of paper, by the way. I'll do that on stream too to prove that point. And then I said I was going to do 5, 3, 1, and 7. Okay. So to show you in the terminal what that just did. Let me switch scenes again. You can see here that the device was successfully unlocked. I then set a new pin, and then it typed the 4 stars, and the pin was successfully changed. Now, anytime I make a mistake, which I'm going to do here now, I'm going to try to make this a little closer so you guys can see it. I'm going to do pound to try to enter the system, and now it wants me to start over, right? So at this point, and now I'm going to try to use the default pin, and it should just bark at me and turn red. Yep, and I got a red light, so it's not happy with me. So that's no good. So I go back into the pin mode, and then I'm going to put in the pin we set earlier that I wrote down, which is 5, 3, 1, 7. And the system is unlocked. Now, something that I had mentioned before, and if this is still true, is if I completely remove power from the board, right? Or I reset the code with the button. That's going to clear all of the variables. So right now I used the pin I set to unlock this. But if I reset the board by clicking the little button, board starts over, and I try to access the system, you're going to notice something. If I do pound and then try to type the 5, it's not happy with me because it didn't hold the pin we set. If I were to have removed power from this, the same thing would have happened. So, what that means for us then, you see right here it says wrong digit, which if I scroll up here, yeah, wrong digit, 0, access denied, right in the log here. What this means for us is that this is not a very practical application for holding a password because there's no permanent storage with the way we're doing what we're doing right now. I don't know yet if the Arduino has any permanent storage on it. I don't think so, but I don't know. I haven't done the research yet on that, so I'll be curious to see if we do come along something like that. But as it stands right now, if you wanted to use this for the exact application we have, you would have to have the board never lose power for it to be user changeable. This would work perfectly fine if you hard-coded a real password or pin into the device, but then if you wanted to change it, you would have to plug this into the terminal and change the code and re-upload it to be able to change the pin. That would make it fairly secure, assuming no one had direct access to the USB port that's on the device. I don't know if it's possible to pull the sketch back out if you didn't have it saved. I would imagine you probably could, right? Because it's running it, so it's stored in memory somewhere. In the the read-only memory, or the non-volatile memory. Well, actually, I actually answered my own question. Of course, this has storage. I put the code on it. If it had absolutely none, then I would have lost my code when I removed power. So yes, this does have storage that can persist between reboots, but I don't know how one would store their data into that memory. I'm sure it's possible. I'm sure there's a way to do it, but this example hasn't done that yet. So I'm imagining that's probably going to come up in future conversations. Whether it's going to come up in this particular kit or not, I don't know. I do know that sooner or later I'm probably going to want to know the answer to that question. But that is where that's where that leaves us. So that is wow, all right. I thought this was going to be about 45 minutes worth of stuff, but this was a 2-hour stream. So never mind. I was wrong. But that's okay. I was wrong in the best way possible. I'm hoping that I have broken that down in a way that was hopefully understandable. Yeah. So for next time, let me look at my calendar here. My calendar. Preferably the one that has stuff and things on it. I should be back for next Wednesday. So I stream on Wednesdays around 6:30 Eastern time. Sometimes, like today, I had a later start, so it was closer to 7. But if I stream, it's Wednesdays. I've been toying with the idea of having an extra stream in here or there, but nothing has come from that. Right now, it's just been Wednesdays in the evenings. So if you are looking for me to be live, yet again, that is when you will find me. And with that, let me see where we can all wander off to. Because there's lots of folks on right now. Let's see here. Give me a moment while I peruse through who is here. Because I think I know where we're going to go. I just want to make sure that they're still alive at the current moment. Because it wouldn't be the first time that I've done that. Yes. Yes, they are. All right, good. That's where we're going to go then. All right, so for our raid message, we are going to do oh, nope, that's not what I want. I want emotes, please and thank you. Okay, so our raid message is going to be Blinks and Beeps from Electronic Land. So we're going to use that for our raid message. And then we are going to go pop over to Cad Pig Jr., who is currently playing the game Borderlands 2. Always gotta love some of the older games. Fantastic. So with that, I thank you all very much for sticking around from the raid. That was very much appreciated. And for those of you who wandered in, thank you. And I'll see you all around for next Wednesday, hopefully. I do update on Twitter and Blue Sky if something changes. So you will find me on those platforms with the same name. I'm TechKid41 in both places. Because there's really no decent way to say on Twitch that you're not here if you're not here, because you're not here. So fair enough. With that, I thank you all for stopping by and enjoy the rest of your night or morning. Bye-bye.